Okay, so we're going to get started. And I have the two example problems that I had loaded. Hi, Beth. Um, the two example problems that I loaded on Monday. And that way we can get a good review as to just how to set up the ratios. And then what we'll do is show how we're actually going to use these. So, wanted to just kind of go through that real quick. So here's what our first problem looks like, and I even wrote down each of the ratios already for us. And it does say that we want to write all the trig ratios for the acute angles, so we want to pay attention to the fact that we don't want just one, we want all three, and we don't want just one of the angles, we want both A and C. How are you doing, Siona? Glad you guys truly help me get through this every day. You really don't know. I know it sounds kind of corny, but it really does help to know I'm talking to somebody while I'm doing this. So Siona, we just said that we're going to write all of our trig ratios, so that's sine, cosine, and tangent, all three of them. And we're not doing it for just one angle. We're doing it for both because it does say angles. So the first thing that I want to do is I'm going to, because we said A, I'm going to, good job, Angie. We're going to go ahead and circle A. And what we said is once we know what angle we're looking at, we have to then determine opposite, adjacent, and hypotenuse. The hypotenuse, in my opinion, is the easiest because we've been naming it all year. The side that makes the angle with the hypotenuse is our adjacent side. And the side whose name, CB, the segment CB, notice it doesn't have the letter A, that's our opposite. And again, we've been talking about opposite a lot as well with our triangle inequality work. So now that I've labeled, I can try to remember that sine, if we don't remember SOHCAHTOA, helps us to know that it's supposed to have the definition opposite over hypotenuse, which means opposite over hypotenuse, my answer for this would be 12/13. And the nice thing is there's no reducing that has to happen. When we look at what cosine is, so that's adjacent over hypotenuse. We have 5/13. And then tangent, so TOA, opposite over adjacent is its definition. That's going to end up being 12/5. And I understand that's improper. But again, we're talking about ratio. We're not talking about solving for anything or giving anything as a final answer. So here are the ratios for angle A. It does say both angles, so what we need to make sure of is that we are dealing with both. So we're going to come back up here to angle C. And we're now going to identify our hypotenuse. Adjacent, again, is the side that makes the angle. So adjacent and opposite. So I'm not going to rewrite our definition, but this time opposite over hypotenuse would be 5/13. And we talked yesterday about recognizing our pattern. The cosine of an angle and the sine of the other angle should match. Adjacent over hypotenuse, sine of the angle and the cosine of the other should match. And then our tangent of our angle, 5/12, those guys should be reciprocals. And the whole purpose is we don't want 5 to move. It's the length of AB. So I have to make sure that anything that works with this specific side has to relate the same way. If cosine here and sine here, they have to make sure that they have that same relationship. We can't move those lengths. So as we switch angles, these things change here, and that's why sine and cosine change. So those are our answers because we just wanted the ratios. And you're done. Again, most of that is just practice, but that's what we were working on, is practicing writing the ratios. So we gave another example, same idea, except instead of labeling the triangle finished already, they want us to use our vocabulary and our definitions to help create the triangle ourselves. So up here, I have to remember that sine, the top one is opposite. The bottom one is always supposed to be the hypotenuse. So right away, if this is the right angle, I know this is the hypotenuse. I'm going to put 25 right here. Has to be. Told me it right here. And because I'm at angle G, opposite is over here. And they already told me that the opposite is 24. So that means I only need to figure out the length for the adjacent side in order to finish these. Because I need adjacent if I'm going to do cosine, because cosine's adjacent over hypotenuse. And I need adjacent for tangent because it's opposite over adjacent. So I can go through and I could do it by the Pythagorean theorem. I obviously chose these numbers for a reason, though. And instead of gi squared plus 24 squared equals 25 squared, this is a Pythagorean triple. And we talked since September about all the triples: 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17. We talked about 7, so 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17. We also talked about 9, 40, and 41, 11, 60, and 61. So in this case, it's a Pythagorean triple, 7, 24, 25. So I already know whether I solve it with the Pythagorean theorem or I have it memorized that it's a triple. 7 is my answer for GI. So when I fill in cosine, I now know that that's going to be 7 over 25. And tangent is opposite over adjacent, so 24 over 7. To do H, we've already filled in. So here's now our opposite. Here's our adjacent, and again, the hypotenuse will never change. So sine H is 7 over 25. Cosine H is 24 over 25. And tangent H is 7 over 24. And again, the pattern holds where you should see those switch so that the lengths of the sides don't move around our triangle, and those two should flip. So, two different ways that you'll see these ratios be used, but the idea is to get comfortable with what opposites and adjacents are and how to set up the ratios. as we start to switch gears, what I am going to ask ladies is if you have any questions while we're live, that you type them in. For those of us that are hopefully watching on our own time, that you email me. One of the things that I'm finding is I'm getting a lot of emails about late work. Can I hand in late work? I think at least the two of you have probably heard me say more times than you care to hear, there is no such thing as late work. There is only work that hasn't been turned in yet. And I'm trying to give us these benchmark dates so that we stay organized. So like, for instance, the last of the no reassignments should have been turned in on the 9-3, definitely should have been turned in by Sunday, and the 9-4 should be finished by the end of the week. However, if they're not turned in, they can always be turned in up until the end of the quarter. So for those of us that are concerned about missing work, it's not missing, you just haven't turned it in yet. It also helps, I have a lot of people who are trying really hard to get caught up. I will be very honest, I don't lie, you know that sometimes I'm brutally honest. But we've had a lot of people who have emailed, I'm trying really hard, I'm just so confused. But as the two of you guys can see, you're here, you're paying attention every day, you're both doing well, but you're here with me every day. And even those that aren't here right now, I can go in and see who's watching. So the people that are struggling are the ones that aren't even watching anything. So I'm trying to do my best to help with homework problems. I'm trying to give us answers to homework problems. So we need to watch the videos. We need to pretend like we're sitting in the classroom and we're just not talking back and forth to each other. So that's kind of my thing right now, is we need to be active even if we are at home. So right now I've switched gears. You can see up here I've talked about we're going to find side lengths using our trig ratios. So what that's going to look like is you're going to be given a right triangle. And unlike our special right triangles, we're going to have a measure, hey Xander, that isn't 30, 60, 90. It's not 45, 45, 90. In fact, I'm going to make this angle measure 71 degrees. So clearly not one of our special measures. And I'm going to ask us to find, let's just start with X and Y, and we're going to go ahead and we're going to name this guy X. We're going to name the hypotenuse Y, and we'll go ahead and name this side 22. So we concentrated so much already, and I know, Xander, you just, I don't know if you've been here, but we did all of this practice with setting up the ratios. And that was huge, because that's what we're actually going to use here. We just don't have to write all of them now. We just need to do enough to solve. So I'm going to start this problem exactly the same way. And I find that consistency is huge when we're trying to create this like muscle memory. When we do things, we can see what the problem looks like and we automatically go into the same habits that we've done before. So the first thing I'm going to do is I'm going to find the angle that they've labeled. And so I'm going to create our steps. So first, find the given angle, circle it, and label opposite, adjacent, and hypotenuse. So that's going to be the very first thing we're going to do. We're going to circle our angle. We're going to label opposite, adjacent, oops, that's a D and a J combined, and hypotenuse. All right, so that's our first step. Our second step pick the first variable or side to solve for. Well, I think we're all okay if I choose to solve x. So I'm going to choose to solve x. And when I chose to solve x, I recognize that x is on the adjacent side. Okay? So of all of my trig functions, and again, if I don't have them memorized, remember that sine of an angle, remember theta is our angle word, our angle letter, just Greek, and sine is opposite over hypotenuse. Cosine of our angle is adjacent over hypotenuse, and tangent of our angle is opposite over adjacent. Again, we want to always keep that in mind so that we don't forget. And the reason that's important is I should be able to see that two of my three ratios have adjacent. So what that tells me is if I'm going to solve for x, which is on the adjacent side, I don't care about sine. Sine doesn't have adjacent. I've narrowed it down to these two. So then, look at the value that they give us. The value they give us is 22. 22, that's on our opposite side. So what's important here is that this one is not only adjacent, but it also has opposite. So I've now narrowed down which one I'm going to pick by what sides I'm working with. I chose x to solve for. They gave me 22. So with adjacent and opposite, I have to pick tangent. It narrowed it down to tangent. So our third step is then going to be with the correct trig ratio, set up the equation. Substituting in all values. All right, so we're going to substitute in all of our values. And I'm going to do that work up here. So that means I'm going to take tangent, and instead of theta, I know that theta stands for the angle. Well, the angle is 71. So we're substituting that in. And our opposite side we know is 22. So we're going to go ahead with opposite 22. And our adjacent side is x. So now instead of us just writing out the definition, which again, it's an equation because of an equal sign, I've substituted in each unknown. 71 was our theta, it was the degree. Our opposite side was 22, and the adjacent side was x. So now we have an equation that we can solve. The next step is we have to use our calculator. And I talked about this a little bit on Monday, that our trig stuff has to use a calculator. So I need to go to my calculator to find what the ratio is for tangent 71. I'm going to say that again. I need to use my calculator to find the decimal version. We know that 1/2 is 0.5. We know 3/4 is 0.75. Most of us know that 0.333333 is 1/3. So there are decimal versions of what our ratios look like. So remember, tangent is a ratio. Our calculator has stored on it for every decimal, it has what the ratio would be for every angle, and vice versa. So for every angle, there's a decimal version of the ratio stored in this calculator. There's an algorithm that it runs on. So if I want to know what this ratio is supposed to come out to be, it's equal to what's on this side. That's what an equal sign means, remember? So when I go to my calculator, I'm going to push the button for tangent. It looks like that on my calculator. And then I'm going to plug in the 71 degrees. Remember, we talked yesterday about if you need to change it to DEG, we push this button here, and that way we can get to degree. Mine's already in degree, so we're good. And then I'm going to push enter. And that right there, 2.904210.878, this decimal is what this ratio should work out to be. So what I'm going to do is I'm going to now put 2.9042, and I know it goes further, but I'm only writing down a few places. And I'm going to set it equal to 22 over x. And that's because this decimal version should be what this works out to be. And I reminded myself it was a ratio by putting it over 1. And I will always put it over 1. Because now I have two ratios set equal to each other, and that's a proportion. So our last step is to use the proportion to solve. And we know with proportions that means cross multiply, and solve. Oh my goodness, Angie, letters backwards, 2 words back to back. Cross multiply and solve. So we're going to cross multiply. So with this decimal, we created our ratio, and now our proportion we're going to use to solve. So we're going to cross multiply here, and we end up with 2.9042 times x equals 1 times 22, which will just be 22. Notice that my calculator, I've not erased this. Well, that's because I still need that number, because if I want to get x by itself, I have to divide both sides by this number. And that is a heck of a decimal to have to plug back in. And I'd like to make life easy. So instead of clearing my screen, I'm going to cut and paste this. So watch, I didn't clear my screen. I'm going to now plug in 22. So it disappeared, divided by, and now I want to put all those decimal places back. So I'm going to do second, and then I'm going to push this button right here for the second answer. That's that cut and paste. And so now all those decimal places went in there, and when I push enter, there's the value for x. And we're going to round it to the nearest tenth pretty much every time. So let's review that real quick. When you round to the nearest tenth, don't forget, there's our tenths place. We have to look right there. If that number is 5, 6, 7, 8, or 9, that bumps this number up 1. So that'll become 0.6. If this number was 4, 3, 2, 1, or 0, it would stay 5. So that's why this is going to be 7.6 approximately. So we just found x. We're going to repeat the steps. And so I'm not going to rewrite it. I'm just going to go repeat for y. And all that means is y is our hypotenuse. 22 is our opposite side. So if we're doing hypotenuse and opposite, the only one that uses hypotenuse and opposite is sine. And that's because sine theta is opposite over hypotenuse. So every step we're going to redo now. And this is the nice part, because you'll be able to see now that we're going to do sine, it's going to go a lot faster. So we have sine of 71 equals, notice it's not tangent anymore. We determined it had to be sine because our y is the hypotenuse, and the side given to me was opposite. So opposite and hypotenuse fit this formula. So opposite is 22, hypotenuse is y. I go to my calculator, and this time we plug in sine of 71. So I use this ratio. And again, we're going to write down just a few decimal places. Oh, and honestly, how many decimal places am I using? It doesn't matter. It's just for me to see, because I'm including all the decimal places on my calculator. So that's why you even see that sometimes when I'm doing my work that it's not rounded correctly, because I'm not really using that as a final answer. It's just to kind of keep track. So Beth, I'm just writing down, most of the time you'll see I always write 4 places, but I know all the places are stored here when I do that second answer step. So it's just so that I can keep track of how to do my proportion. So then when I cross multiply, we end up with this 0.9455y equals 22. We are going to divide both sides, and here's why I said the calculator stores all those places. So we're going to divide both sides, and notice I ran out of room, so I just put 0.94, because again, it doesn't really matter. It's just for me to keep track of the process, because now on my calculator, I'm going to do 22 divided by second answer, and all the decimal places got involved, and then I push enter. So a lot of people, what they'll do is after they get a hang of this, if they're confident, they'll only put 1 or 2 decimal places because they know that all of it's coming from here. Now the final answer, remember, we round to the nearest tenth unless otherwise told. And this guy too had to round up because 6 was the next number. And that's it. So I am going to do one more example before I give you some practice problems to try, and then we will go over another few on Friday. We won't do a whole bunch on Friday. We're just going to practice sides again. But you have all the steps here. Find what angle they're talking about and circle it. Label opposite, adjacent, and hypotenuse. Pick the first variable to solve, whatever side you want, and then we chose X. That was adjacent. We looked for the value. That was opposite. And then we figured out what trig one that matched with. With that correct trig ratio, we're going to set up our equation, substituting in all of our values. We have to use our calculator to figure out what that version, that decimal version of the ratio is for that. We then did our proportion and we cross multiplied and solved. We then repeat for the other side. So without all this getting in the way, let's do one more example. And I'm going to ask the same question, just make it look a little bit different. Oops, that was ugly. So here's B. Here's A, and here's C. I already gave you one like that, so sorry. I know you guys are gonna get mad. That and I messed up the B, so made me mad. It's gonna read the same, but I'm gonna fix my triangle. That's a little better. I wanted to put B here and I messed up. So that's what I wanted it to look like. And I'm going to tell you that this angle over here is 12 degrees. Trying to make things a little way different from 30, 60, and 90, and 45, and 45, and 90. So I want to make sure it looks different. And I'm going to tell you that this side is 30. We'll make that 30 meters just for the example. And I know that I'm going to use trig. And here's the big, because everybody goes, well, how do I know what to use and when? First thing I do is I look at the angle. That's anything with geometry. The first thing I'm going to do is I'm going to look at the angle, and I'm going to tell that it has to be trig because it's not 30, 60, or 90, and it's not 45 or 90. So that's how I know it's got to be trig. I also know it's got to be trig because only one side length is given. I don't have 2, so I can't use the Pythagorean theorem. So it kind of narrows it down when I'm looking at what the triangle is. So when I look at the triangle, I can see that only one side length's given, so I can't use the Pythagorean theorem. I look at the angle measure and I see it's not one of our specials, so it has to be trig. So that's when we start our process and we circle our first angle, the one that they told us to concentrate on specifically because they gave us the measure. We know that we have opposite, we have adjacent, and then hypotenuse. And I pick which side I want to solve for first. So I'm going to go ahead and pick AB. So AB is opposite, and hypotenuse is the only one given. So when I go to work this problem out, I know that opposite and hypotenuse is, again, our sine function. And if I can't remember that and I don't have my formulas in front of me, don't forget that your mnemonic device, the way to memorize it is SOHCAHTOA. So I can look here and see that O and H are right here, so S stands for sine. So I chose that because it has to go with what pieces I'm working with. So we choose sine theta would be opposite over hypotenuse. That's what this told me. And so now I'm going to plug in all of my unknowns. Sine of 12 equals opposite, which we'll call AB because we don't have X or Y this time. And our hypotenuse is 30. So when I go to the calculator, it's going to tell me what to plug in. So we're going to plug in sine 12, enter. And now that we have our calculator version of our ratio, we're going to write that decimal down. So 0.2079, and we put it over 1 to remind me that it's a decimal, and we're using a ratio. And then I rewrite AB over 30. We're going to cross multiply to solve. So again, when we cross multiply, here's what's going to be nice about this one. 1 times AB is just going to be AB. There's nothing to do there. And now I'm going to take that decimal and multiply it by 30. So it's still sitting here on my calculator. This time I just have to push times 30 so that, again, it cut and pastes everything I need. And I didn't have to type it all back in. And I push enter. And again, if I'm going to round to the nearest tenth, 3 is smaller than 5. Remember 0, 1, 2, 3, 4. I keep it as 6.2. So the length of AB is going to be approximately 6.2. So then if I want to solve for BC, BC is on the adjacent side. I'm still working with the number they gave me, which was the hypotenuse. So I look up here, AH. The only one that uses A and H, adjacent and hypotenuse, is cosine. So now that I know what function, what ratio I'm going to use, I'm going to write that out, and now I substitute in each unknown so I can solve the equation. So this time it's cosine of our angle. We don't know what the adjacent side is, so we're going to use BC because we don't have a Y or an X, and then our hypotenuse 30. This, remember, stands for that decimal version of our ratio. So I got to go to my calculator. This time it says cosine, so cosine 12, enter, and we get 0.9781. It's a ratio, even though it's in decimal form, so I put it over 1, and I bring down that BC over 30. And again, it's a proportion because it's two ratios equal to each other. We are going to cross multiply to solve. So 1 times BC is going to be BC. And my whole decimal now is being accounted for, even though I only wrote down enough to keep track of the problem. I'm going to take this, leaving it right there, and I'm going to multiply by 30. And I look to see here, and it says 29.34, which means it's barely there, but 4 keeps us at 0.3. We don't round up. So BC will be about 29.3. And because we're talking about meters, I would, of course, label if I was asked to. So we have 29.3 meters, and this guy was 6.2 meters. And it kind of makes sense, because when I look at how this triangle's made up, if that guy's 12 degrees, the other one's got to be 78 degrees. And 78 degrees is pretty close to 90. 29.3 is pretty close to 30, but 30 is still the longest side because it's opposite the largest angle. BC, it's a pretty lengthy size, and it is opposite what would be a much larger angle than 12 degrees, which opposite 12 should be a pretty small, a short side, because again, it's opposite the smallest angle. So keep in mind our triangle inequality when you're checking these. If for some reason 29.3 showed up over here, it doesn't make sense. Opposite the smallest angle should be the shortest side. Opposite the largest angle should be the longest side, and what's in the middle should also match, and it should be pretty close to what those numbers are. So keep in mind you can compare just to spot check yourself as well. So for right now, that's all I want to do. It's us practicing these steps, and every one is the same. We figure out what angle they gave us. We label opposite, adjacent, and hypotenuse. And then we decide for each piece we're solving for, which one of our functions are we going to have to use because of what parts of the ratio we're working with. So I am, like last time, I'm going to give you 3 questions. Make sure that you practice them. On Friday, we will go over those 3. And please expect that the only assignment for this week that I'm giving will also be loaded. So that's all I have for you guys today. Are there any questions? And if you do, you can type them in. Or, of course, you can email me anything and I can respond to you whenever those questions come up. All right, if not, we will talk to you guys on Friday. Keep a lookout in Google Classroom, and I hope you guys get to go outside and enjoy some sunshine. Talk to you guys on Friday. Thanks again.